Okay, we have the situation here, and you can read it. Pause it for a second and read it, but I'm going to move through it. So we want to know how unusual this result was, getting 485 packages arriving on time if the chance of a package arriving on time is 85%. Notice this situation is definitely binomial. I have a fixed sample size, 610. I am going to do this sampling, and during that sampling, the probability of success, 85%, is holding steady throughout. Now, when I sample, I am sampling without replacement, but again, my sample 610 is just a very small sample compared to the population of all the packages being shipped. So I'm going to pretend like I have independence. In other words, I'm going to pretend like I am sampling with replacement. Okay. Lastly, everything is success and failure. Yes, it meets that criteria. Either arrives on time or it doesn't arrive on time. So we have this situation. What I want to also notice now is that my sample size is rather large, and I meet this following criteria. In other words, 610 times 85% is clearly bigger than 10, and so is 610 times 1 minus 0.85. Both are greater than 10. So I can invoke the central limit theorem, which says that if my sample size is large enough, then the distribution, in this case, of sample proportions will be approximately normal. So the way I'm thinking about it is this. This distribution is approximately normal, or at least has that normal shape. The center of this is 0.85, and it is the distribution of every single sample proportion I can think of. And the reason I can put 0.85 here, in other words, why is it this the mean, is because I'm assuming that the distribution, the sampling methods, is unbiased. So this is why I can do this. Okay, so what is the p-hat value that was produced here? So the p-hat value in this case is going to be 485 divided by the sample size. I have 485 successes out of 610 attempts, and this is approximately 0.07951. Now, the question really is, here is this value. Is this difference large or small? How likely is it to get a sample proportion as low as 0.7951 if the true proportion is 85% from a sample size of 610? So to answer this question, what I want to do now is I'm going to calculate the area to the left. So the question really will turn into, how likely is it to get this value or something even more unusual than this? Where does this number belong to? So I'm going to take this number and calculate its z-score. And when I do that, I get the following. Approximately, I'm going to round it to 2 decimal places. As a matter of fact, if I round it to 2 decimal places, I get this. Okay, and how am I going to calculate this now? So it turns out that this value, 0.7951, is way more than 3 standard deviations away. It's nearly 4 standard deviations away. So now I realize that this number is very unusual, but I'll still go through the process here. So what I want to do is calculate the chance of getting a p-hat value less than or equal to 0.7951, and that's approximately equal to finding this from a normal distribution. If I'm using Excel, for example, the command would be norm s dist -3.80. If I'm using GeoGebra, I'm going to enter, again, notice I'm using a normal calculation. I'm going to enter -3.79, but it turns out to be -3.80 if I round. So let me enter that. Hit return. And I get 0.0001. In other words, this has been rounded to 4 decimal places, but this value is very unusual. So let me go back. So this is approximately 0.0001. An extremely unusual value. A result this far away from 85% or 0.85 only happens, basically this is the tens, hundreds, thousands, 10,000. So 1 out of every 10,000 attempts would you get to see a result this extreme or even more extreme. So really, to answer this question, does this provide any evidence that the claim of 85% is correct? The answer is yes. The result is very unusual. If we assume %85% is the correct arrival time.